Hi everybody. Today we're going to be talking about multiplication word problems and different strategies that you can use when you approach different kinds of word problems. So, first of all, let's talk about some keywords that you might see when you come across multiplication word problems. So, you might see equal groups, you might see equal rows, you might see words like each, like in each row, or each group needs this many, or each column needs this many. Or you might see the word times, or such as this phrase, times as many, like I have 6 times as many coins as the person next to me, something like that. Other things I want to talk about are some simple tips. So my first tip is that you want to make sure that your number sentence or equation matches the words in the problem. This is probably the most important tip I can give you because equations are going to be your best friend when you go to try and solve things, because there might not always be one step to the problem for you to solve in your head. You might need to write it out, and so an equation is going to be important for that. Some other tips. I always say to my students, when in doubt, draw it out. You can go back to the most basic concept. When you're not sure what the equation is, draw out what you think the problem is saying, and it might lead you to an equation. It might lead you to an answer. And then lastly is make sure your answer makes sense for the type of problem. If someone is 10 times taller than another person, their height is going to be much bigger than the original person. They're not going to be shorter. You want to make sure that they match. Okay, so we're going to jump right into solving this problem here. And we're going to start by spotting some keywords. So, it says a dog groomer earns $10 an hour. If she works 8 hours in one day, how much money would she earn? Not seeing any of those keywords, but there's a lot of clues here to tell us what kind of problem this is. So, first of all, I'm going to go ahead and circle the numbers here. So she earns $10 in an hour. And if she works 8 hours in one day, how much money would she earn? Okay, so $10 in 1 hour. And then it says that she works 8 hours in one day. So if we want to know how much she earns in that day, then we need to take our $10 and multiply it by 8. So that would be the same as having, so if we had 8 hours and there were $10 in every hour, that would be 8 groups of 10. 2, 3, 4, 5, 6, 7, 8. 8 groups of 10. We also know that 8 groups of 10 is an abbreviation for our multiplication symbol, 8 times 10. Okay, so both our picture of drawing it out and knowing that we need 8 groups of 10 matches this number sentence, 8 times 10. Now we can solve. So 8 times 10 would be the same as having 8 times 1, which would be 8, and then add our 0 at the end. So it would be $80 is what our dog groomer would earn in a day. It's good money. All right. Next, I want to talk about when you come across something called multiplicative comparisons. Okay? These are just fancy words for when you're using multiplication to compare two things. So this is the instance where you're going to see the word times a lot. Times as many as something. So let's look at this example. Jack's son is 2 feet tall. If Jack is 3 times taller than his son, how tall is Jack? Right? 3 times taller than his son. How tall is Jack? Well, what do we know? We know Jack's son is 2 feet tall. So I'm going to write son equals 2 feet. That's something I know right off the bat. Now, I also know Jack is 3 times taller than his son. 3 times his son. Now, I can fill in those blanks. This is kind of like a question mark almost, but I know what to fill it in with. If Jack is 3 times the amount of his son's height, and his son is 2 feet tall, then Jack is 3 times what his son is equal to. 3 times 2 feet. So Jack would be 6 feet tall. It really helps to write out what you know, and then you can solve for what you don't know. This was my equation. My equation also could have been 3 times question mark. Okay, but I wrote son because that's what it said in the problem, and I was able to easily fill in that blank with information I already had. Let's look at another one like that. Okay, here we have a problem that says JT picked 5 times as many apples as Braxton. So it comes right out with that multiplicative comparison. If Braxton picked 20 apples, how many apples did JT pick? All right, well, let's start with what we know. We know how many Braxton picked because it tells us right in the problem. So I'm going to write B short for Braxton. So Braxton equals 20 apples is what Braxton picked. And then now we want to find, we're trying to solve for what JT picked. Well, we know that JT picked 5 times as many as Braxton. So I could write 5 times Braxton, or B short for Braxton. Okay, so just like we did in the last problem, we can fill in that B for Braxton with Braxton's amount. Braxton picked 20 apples, so JT picked 5 times Braxton's 20 apples. And if you look at this problem before I solve this, you're going to want an answer that means that JT picked more than Braxton. He picked 5 times as many as Braxton. That's usually going to tell you that he picked more. So your answer is going to be a bigger number than the 20 apples. So here we have 5 times 20. We can use our zero trick again. 5 times 2 is 10. I know there's a 0 in the 10, but there's still an extra 0 to be added at the end here, because 5 times 2 on its own would be just plain old 10. So we add the 0 to make it 100. So JT, he must have had a fancy machine for his apple picking. I'm sure Braxton's a pretty fast picker. All right, last kind of problem that you might see today is a multi-step problem. So that's where you're going to solve for one answer, and then you might have to do a second set of equations, or you might have to add on, or whatever the answer, whatever the question is trying to get you to say. You want to think it through carefully, because you might have to do more than one step. Here's my hint to you. So, let's look at this example here. My mini fridge holds 6 water bottles in a row and 4 rows all together of water bottles. How many water bottles could I hold if I bought a second mini fridge? All right, so first thing I noticed off the bat is this keyword, second mini fridge. I only talk about how much my one sole mini fridge holds on its own. I don't have a second mini fridge yet, so I don't know how much it's going to hold unless I buy the same mini fridge a second time. So I'm going to start by solving what's my mini fridge hold right now on its own, and then I can figure out from there how much a second one would hold. And I'll talk about what I mean by that once we get through the first step. So first, my mini fridge holds 6 water bottles in a row and 4 rows all together. 6 in a row and 4 rows all together. Well, if I was going to draw this out, 6 water bottles in a row, I'm just going to draw little squares for water bottles. 1, 2, 3, 4, 5, 6. There's my 6 water bottles in one row, but I have 4 rows. My mini fridge goes pretty deep. I can hold 4 rows of those 6. So 1, 2, 3, 4, 5, 6. This is 2 rows, so I need 2 more rows. I could draw this whole problem out to find out how many water bottles my mini fridge holds in all. Now, you notice I've made an array. So I could individually count all of these water bottles one by one, but I also know by arrays that I can just multiply to find out what's inside, right? So I've got 1, 2, 3, 4, 5, 6 by 1, 2, 3, 4 array. I've got a 4 by 6 or a 6 by 4 array, whichever way you look at it, which means my equation for what one mini fridge holds, I'm going to do that in a different color. So one mini fridge holds 6 groups of 4 or 4 groups of 6. Really, it holds 4 groups of 6 water bottles. 6 times 4 would be 24 water bottles in all, and that's in one mini fridge would hold 24 water bottles. But I want to know, if I get a second mini fridge, same size, how many water bottles could I hold in all? Well, I could figure this out in 2 different ways. So I know one holds 24, and so if I just add another 24, I'd find out how many were in 2 fridges. Or I can just take my 24 and multiply that times 2, right? 2 groups of 24. So either way, whether I am adding it up or multiplying it, I would get the same answer. How many water bottles could I hold? If I get a second mini fridge, I could hold 48 water bottles. Okay, so I'll give you a hint. There's definitely a problem similar to this in your questions today. If you are confused, if you want help drawing it out, if you want help with any of these types of problems today, please come visit my office hours, and I will be waiting for you.